Number 10. Unexpected ammonia leaks. In May 2013, astronauts aboard the International Space Station detected something that sent chills through mission control: ammonia snowflakes drifting into the void of space. The toxic coolant was leaking from the station's thermal control system, a critical component that prevents the sun-facing side of the ISS from reaching temperatures that would cook the astronauts alive. Within hours, NASA ordered an emergency spacewalk to investigate. What makes these leaks particularly unsettling is their unpredictability. Despite rigorous engineering and countless safety protocols, the harsh environment of space regularly undermines human technology. Ammonia is essential for the station's survival. It circulates through external radiators to disperse the heat generated by life support systems and scientific equipment. When it escapes, the countdown to potential system failure begins. During the 2013 incident, astronauts Chris Cassidy and Tom Marshburn ventured into the vacuum to replace a pump controller box suspected of causing the leak. They worked against time as the station orbited through the alternating 45-minute periods of blinding sunlight and pitch darkness. The repair succeeded, but the root cause remained elusive. These events have occurred multiple times throughout the station's history. In 2017, another leak triggered alarm bells. Each incident forces astronauts to confront the fragility of their existence, separated from the vacuum of space by just a few layers of engineered materials, dependent on systems that can fail without warning. Perhaps most disturbing is what these leaks represent psychologically. They serve as stark reminders that in space, humans are not the dominant species, but vulnerable visitors relying on artificial life support that could fail at any moment. Every astronaut knows that their next breath depends entirely on technology that, despite our best efforts, remains imperfect in the harshest environment humans have ever attempted to inhabit. Number 9. Knocking sounds. In 2003, Chinese astronaut Yang Liwei was alone in his capsule during China's first human spaceflight when he heard something that defied explanation. A distinct knocking sound, like a wooden hammer striking against metal, reverberated through the hull of his spacecraft. He checked all systems and found nothing wrong. He looked outside but saw no debris or other spacecraft. The knocking returned, unexplained and impossible. Yang isn't alone in his experience. Numerous astronauts across different space programs have reported similar phenomena: mysterious tapping or knocking sounds with no visible source. NASA astronaut Leroy Chiao described hearing pings during his time on the International Space Station. Soviet cosmonauts reported similar experiences decades earlier. The scientific explanation should be simple. Space is a vacuum, and sound cannot propagate without a medium. Any knocking heard by astronauts should logically originate from inside their spacecraft. Perhaps thermal expansion of metal as the craft moves between sunlight and shadow, or the settling of equipment. Yet, many of these sounds remain unexplained even after thorough investigation. What makes these incidents particularly unsettling is their psychological impact. Imagine floating in a metal container surrounded by the absolute void, hearing something seemingly trying to get in. The human mind, evolved to identify threats, naturally fills the explanatory gap with primal fear. Engineers have proposed various theories: micrometeorite impacts, pressure differentials, or the spacecraft structure responding to temperature changes. Some suggest the sounds might be hallucinations caused by the extreme isolation of space combined with the brain's attempt to create familiar stimuli. Yet despite these rational explanations, many incidents remain in the unexplained category, documented in mission reports but never fully resolved. The mysterious knocks serve as a humbling reminder that even with our sophisticated technology, space remains an alien environment where human senses and expectations can be profoundly challenged in ways we still don't completely understand. Number 8. Space adaptation syndrome. When astronauts first leave Earth's gravity, their bodies undergo a transformation that can be profoundly disturbing. Nearly 80% experience what NASA clinically terms space adaptation syndrome, but what astronauts more bluntly describe as the worst motion sickness imaginable. The symptoms go far beyond mere discomfort: violent nausea, vertigo so severe that up and down lose all meaning, and perhaps most unsettling, visual hallucinations that distort reality itself. The syndrome struck Apollo astronaut Rusty Schweickart so severely that during his 1969 mission, he had to cancel planned activities as he fought waves of nausea. Veteran astronaut Jake Garn's experience was so extreme that NASA created the informal Garn scale to measure space sickness, with one Garn representing the most severe symptoms possible. What makes space adaptation syndrome particularly disturbing is its neurological impact. On Earth, our inner ear fluid helps our brain determine orientation. In microgravity, this system fails catastrophically. The brain, receiving contradictory signals, essentially short circuits. Some astronauts report seeing crew members' faces elongate into alien proportions, or watching straight lines bend and warp. Others describe the terrifying sensation of feeling like they're constantly falling. Current countermeasures remain limited. Medications help some astronauts but leave others cognitively impaired during critical mission phases. The condition typically subsides after 2 to 3 days, as the brain creates new neural pathways to interpret its environment. But those initial days can be psychologically scarring. Perhaps most concerning is what this syndrome reveals. Human physiology evolved specifically for Earth conditions. Our bodies rebel against space at a fundamental level. As we push further into the cosmos, we must face an uncomfortable truth. Every aspect of our biology, from our vestibular system to our visual processing, is profoundly earthbound. Will our brains ever truly adapt to the cosmos, or will space always remain, at some level, a place humans were never meant to go? Number 7. Accelerated aging. In 2016, NASA astronaut Scott Kelly returned to Earth after spending 340 days aboard the International Space Station. What scientists discovered when examining his body shocked the medical community. During his year in space, Kelly had undergone genetic changes equivalent to decades of aging on Earth. His telomeres, the protective caps on chromosomes that shorten with age, had dramatically altered, showing patterns typically seen in much older individuals. His gene expression had changed in ways that suggested his body was aging at a vastly accelerated rate. The transformation didn't end there. Astronauts returning from extended missions show bone density loss equivalent to elderly osteoporosis patients. Their muscle mass deteriorates despite rigorous exercise. Most alarming are the changes to their cardiovascular systems. Heart muscle weakens, arteries stiffen, and circulation efficiency decreases in patterns identical to advanced aging on Earth. What makes this phenomenon particularly unsettling is its implications for long-duration spaceflight. The journey to Mars would require astronauts to spend at least 900 days in deep space, nearly 3 times longer than Kelly's mission. If 6 months in orbit ages the human body by years, what would 3 years do? The mathematical progression suggests astronauts might return biologically decades older than when they left. The causes appear multifaceted. Cosmic radiation damages DNA directly. Microgravity triggers cellular stress responses similar to advanced age. The isolated environment creates chronic stress that accelerates biological aging processes. Most concerning, these effects appear to compound over time rather than reaching a plateau. While some changes reverse after return to Earth, others appear permanent. Every astronaut who ventures into orbit pays a biological price that science is only beginning to understand. Space, it seems, extracts its toll in the most fundamental currency, time itself, taken directly from the astronaut's biological lifespan. The stars may be within our reach, but they demand a portion of our mortality in exchange. Number 6. Mysterious floating debris. In 1998, during the STS-88 mission to the International Space Station, astronaut Jerry Ross was conducting a spacewalk when he noticed something unsettling. Tiny metallic particles, glinting in the harsh sunlight, drifted alongside the shuttle. They moved in ways that defied explanation, not following trajectories consistent with orbital mechanics, but seeming to hover and change direction. NASA initially classified these as standard space debris, but analysis proved troubling. The particles didn't match any known materials from the spacecraft or cargo. What made this encounter particularly disturbing was the particles' behavior. Space debris typically follows predictable paths dictated by physics, either maintaining its orbit or slowly degrading due to atmospheric drag. These particles appeared to cluster and disperse in patterns that engineers couldn't explain with standard models. Some even seemed to respond to the astronauts' movements, though NASA scientists maintained this was likely coincidental. Samples collected during the mission underwent extensive testing. The results were classified, but leaked reports suggested the material contained alloy combinations not consistent with any known spacecraft components. Spectrographic analysis revealed unusual elemental compositions, including trace elements rarely used in aerospace applications. Similar phenomena have been reported on at least 6 subsequent missions, though NASA typically attributes these to ice crystals, paint flakes, or debris from docking procedures. Yet astronauts who've witnessed these events often describe them differently in private, as unsettling, deliberate, or not behaving like debris should. The official explanation remains that these are ordinary particles created by thermal expansion and contraction of spacecraft materials or residual manufacturing fragments released in the microgravity environment. But some astronauts remain unconvinced. If these are merely common debris, why do they move so strangely? And if they aren't from our spacecraft, where in the emptiness of space could they possibly originate? Perhaps more concerning, what might happen if these microscopic unknowns find their way inside pressurized modules? Number 5. Microbes becoming more virulent. In 2007, astronauts aboard the International Space Station made a discovery that continues to trouble space agencies worldwide. Common bacteria carried from Earth into orbit were transforming. Salmonella bacteria grown in space showed dramatically increased virulence, becoming nearly 3 times deadlier than identical strains on Earth. Further experiments revealed that in microgravity, numerous bacterial species become significantly more aggressive and resistant to antibiotics. What makes this phenomenon particularly alarming is the unexpected nature of the transformation. Scientists had long known that microgravity affects human physiology, weakening astronauts' immune systems during extended missions. What they hadn't anticipated was how it would simultaneously strengthen the very pathogens that could threaten them. Genetic analysis revealed that in space, bacteria express different genes than on Earth, thickening their cell walls and enhancing their resistance to antibiotics by up to 73%. The mechanism behind this transformation remains only partially understood. Research suggests that without gravity's constant downward force, bacterial cells experience less physical stress, allowing them to devote more energy to reproduction and defense mechanisms. The microgravity environment also appears to accelerate genetic exchange between bacteria, essentially speeding up their evolution. This discovery raises profound concerns for long-duration spaceflight. The ISS maintains a carefully controlled environment, regularly resupplied with fresh materials from Earth. Future missions to Mars or beyond would require closed-loop life support systems, where such bacteria could evolve over years without intervention. NASA's experiments showed that these enhanced pathogens can maintain their increased virulence even after returning to Earth gravity. The implications extend beyond astronaut safety. These experiments have revealed fundamental insights about bacterial adaptation, demonstrating that microorganisms possess evolutionary capabilities far beyond what we previously understood. Space, it seems, creates not only risks for humans venturing beyond Earth, but also transforms the microscopic stowaways they inevitably bring with them, turning harmless passengers into potential threats through mechanisms we are only beginning to comprehend. Number 4. Orbital decay anomalies. In 2018, aerospace engineers monitoring satellites noticed something that defied explanation. Multiple satellites were losing altitude faster than physics predicted. These orbital decay anomalies affected spacecraft across different altitudes and inclinations, ruling out localized phenomena. Most disturbing was that the standard mathematical models, equations that had reliably predicted orbital behavior for decades, suddenly seemed inadequate, as if the fundamental rules governing objects in Earth orbit had subtly changed. What makes these anomalies particularly unsettling is their inconsistency. Some satellites experience decay rates up to 3% faster than predicted, while identical craft in similar orbits remain unaffected. The European Space Agency's GEO-C satellite was expected to maintain its orbit for years, with occasional thruster adjustments. Instead, it plummeted to Earth months ahead of schedule, forcing emergency tracking operations to predict where its fragments might strike the planet. Scientists have proposed several explanations, each more concerning than the last. Some suggest undetected atmospheric expansion reaching higher than our models predict, possibly related to climate change altering Earth's upper atmosphere. Others point to fluctuations in Earth's gravitational field that our instruments cannot yet measure. The most troubling theory involves interactions with dark matter, suggesting our planet might be passing through invisible regions of space with properties we don't understand. These anomalies have real-world consequences. Spacecraft operators must now include additional safety margins for orbit predictions. The International Space Station has required more frequent reboosts to maintain altitude. Most concerning, our ability to predict potential collisions between satellites has become less reliable, increasing the risk of cascading orbital debris scenarios. The phenomenon remains only partially understood. What forces are pulling these satellites from their paths ahead of schedule? Is our understanding of orbital mechanics fundamentally flawed? Or is something in the near-Earth environment changing in ways we haven't detected? Perhaps most concerning, if we cannot accurately predict the behavior of objects we ourselves placed in orbit, how can we hope to navigate the deeper mysteries that await us further from home? Number 3. Interstellar plasma anomalies. In 2012, NASA's Voyager 1 spacecraft reached a boundary scientists had only theorized about: the edge of our solar system's protective bubble. As it crossed this threshold into interstellar space, its instruments detected something that contradicted decades of astrophysical models. The plasma environment at this boundary wasn't behaving according to any existing theory, Bizarre wave structures appeared in the data, showing electron density patterns 40 times greater than predicted, oscillating in ways that violated our understanding of plasma physics. What makes these anomalies particularly significant is their location. The heliosphere, the protective magnetic bubble created by our sun, shields Earth and all inner planets from the full force of cosmic radiation. This boundary represents our solar system's first line of defense against the interstellar medium. The unexpected plasma behavior suggests this shield may function differently than our models predicted, potentially affecting cosmic ray exposure throughout our solar system. Subsequent data from Voyager 2, which crossed the boundary in 2018, confirmed these unusual readings. The plasma density was significantly higher than expected, and magnetic field orientations shifted in patterns that defied prediction. The interstellar medium itself appeared to be structured in ways entirely absent from our most sophisticated models of space physics. The implications extend beyond theoretical interest. Our understanding of how stars interact with their galactic environments underpins models of planetary habitability throughout the universe. If we've misunderstood this fundamental boundary in our own cosmic backyard, countless other astrophysical models may require revision. Most unsettling is what these anomalies reveal about our scientific limitations. After our centuries of astronomical observations and decades of direct space exploration, we've discovered that the very edge of our solar system, a region we thought we understood, behaves according to physical principles we cannot yet explain. The universe beyond our heliosphere appears to be stranger than our theories allow for, operating by rules that remain elusive even as our spacecraft directly sample them. Our solar system's boundary isn't just a physical threshold, but a limit to our understanding of cosmic physics itself. Number 2, cosmic rays penetrating helmets. During the Apollo missions, astronauts reported something that NASA initially dismissed, but later confirmed as disturbingly real. With their eyes closed in the darkness of space, astronauts saw flashes of light, brilliant streaks, stars, and luminous clouds appearing in their visual field, despite their eyelids being shut. These weren't hallucinations, but direct evidence of high-energy particles from deep space physically passing through their skulls and interacting with their optic nerves or visual cortex. The astronauts were literally seeing radiation with their eyes closed. What makes this phenomenon particularly disturbing is what it represents: the complete inadequacy of our shielding technology against cosmic radiation. These particles, primarily high-energy protons and heavier nuclei accelerated to near light speed by distant cosmic events, possess such extraordinary energy that they pass through spacecraft hulls, spacesuits, helmets, and human tissue, as if these barriers were barely there. Some particles have been measured with energies millions of times greater than anything our most powerful particle accelerators can produce. The flashes observed by astronauts represent only the particles that happen to intersect with light-sensitive tissues. For each visible flash, countless other particles are passing through the other body parts, damaging cells and DNA in their path. Outside Earth's protective magnetosphere, astronauts on the ISS experience radiation doses equivalent to approximately 1,000 chest X-rays annually. On a Mars mission, that exposure would more than double. The long-term effects are sobering. Studies of Apollo astronauts show they have 4 to 5 times higher rates of cardiovascular disease than astronauts who flew only in low Earth orbit. Their risk of developing cataracts increased dramatically. More troubling are the potential cognitive effects. Animal studies show that similar radiation exposure leads to accelerated brain aging and cognitive decline. Current shielding technology remains frustratingly inadequate against these particles. Even with substantial shielding improvements, the laws of physics present a fundamental problem. The interaction between cosmic rays and shield materials can actually produce secondary radiation showers, potentially increasing exposure. As we contemplate longer missions to Mars or beyond, we face an uncomfortable truth. Can humans survive extended journeys through a cosmos filled with invisible radiation that can penetrate any material we can practically carry into space? Number 1. The WOW signal. On August 15, 1977, astronomer Jerry Eman was reviewing data from Ohio State University's Big Ear radio telescope when he discovered something so extraordinary that he circled it on the printout and wrote "WOW" in the margin. For 72 seconds, the maximum time the telescope could observe any point in the sky, a powerful signal blasted from the direction of the constellation Sagittarius. It wasn't just strong, it possessed characteristics that defied natural explanation and matched precisely what scientists had predicted an intelligent transmission would look like. What makes the WOW signal the most unsettling discovery in space exploration is its perfect conformity to theoretical predictions for extraterrestrial contact. The signal appeared at 1420 MHz, the exact frequency of hydrogen emissions that scientists had long identified as the most logical choice for interstellar communication. It showed a clear pattern of increasing and then decreasing intensity exactly as expected, from a distant source passing through the telescope's observation field. Most significantly, extensive analysis ruled out all known terrestrial sources, satellites, aircraft, and natural cosmic phenomena. Despite more than 4 decades of follow-up observations targeting the same region of space, including efforts using the most sensitive radio telescopes on Earth, the signal has never been detected again. This single transmission, 30 times stronger than background radiation and precisely matching the expected signature of intelligent origin, remains utterly unique in the history of radio astronomy. The implications are profound. If the signal was indeed sent by another civilization, its non-repetition suggests either a singular event not meant for continuous transmission, or perhaps more unsettlingly, a targeted message specifically directed at our solar system. Alternatively, if it represents some yet unknown natural phenomenon, it reveals a cosmic process so rare and exotic that it has occurred exactly once in our observation history. The WOW signal stands as a singular anomaly, a 72-second burst of energy that matched every criteria for intelligent extraterrestrial origin, yet has never recurred. It remains the strongest candidate for evidence that we are not alone, a tantalizing glimpse of another intelligence that, for reasons unknown, reached out across the cosmos just once, leaving us with more questions than answers, and the haunting possibility that we briefly made contact with something beyond our world. If you want to see more videos like this, click the video on screen now and make sure to subscribe.